The figure shows the graphs of the function f, the first derivative f prime, the second derivative f double prime, and the third derivative, which is f triple prime, and we want to be able to identify each curve. So if you take a look here, let's take a look at where the x-intercepts line. Take a look at the horizontal tangents. So there's a horizontal tangent here for graph A, and it does not have an intercept there. Same thing here with B, and C has a horizontal tangent. Now if we look at D, they have two horizontal tangents. There's one here, and then there's one here. Now if you take a look here, that horizontal tangent then has an x-intercept here, and then it has an x-intercept here. So we can say that D is going to represent the first function, which then means what? That means that if we take a look at C, and let's take a look at this. So you can see here that the slope is rising up, and then it gets to 0, and then it decreases to the next x-intercept, and then increases. So you can see here it's decreasing, gets to the x-intercept, continues to decrease until it gets to the next intercept, and then continues to increase. So what does that mean? That means that C then is going to represent the first derivative. So now that we know that, now we need to take a look at, okay, what about the slope? Okay, so if we take a look at the slope on the graph of C, here is that tangent line that represents a slope of 0. And that means that we now have an x-intercept here at 0. Okay, so now we need to determine, okay, which one of these graphs, A or B, represents the second derivative according to the first derivative. Well, let's take a look here. We can see that this graph starts at negative. Let's say the slope is negative. The slope is negative. The slope is negative until it gets to 0. Keeps decreasing, decreasing until it gets to 0, and then it starts increasing. Well, here, this slope would not start at the same part over here. The derivative would have to start down here. And therefore, that means it's going to have to continue to rise, and then get to 0, and then continue to rise here. So what that means is that B is going to represent the second derivative. And therefore, we have the second derivative. Now you can see, now here's the tangent line, okay, for B. And that tangent line is going to have the x-intercept at 0. So now let's take a look here. Now here is the slope, but it's a positive slope. So that means you'd be starting up here, and then it's decreasing. And then it's going to go back up. So therefore, we're going to say that A is going to represent the third derivative. Now let's just go ahead and then see how to write this out. Again, where D has horizontal tangents, only C is 0. So we would say that D represents the function C. Now C has negative tangents for x is less than 0, and B is the only graph that is negative for when x is less than 0. So we said C prime is equal to B. And B has positive tangents on all real numbers except at 0. And the only graph that is positive on the same domain is A. So therefore, we would say that B prime is A. So we would conclude that D represents, again, the function f. C represents the first derivative, f prime. B represents the second derivative, f double prime. And then A represents the third derivative, which is f triple prime.